solubility and dissolution similar? We've got these questions from some of you guys after our last video of solubility. So today we will know what dissolution is and how it happens. And by the end of this video, you will be able to answer that question yourself. So keep watching and enjoy the next minute's learning. Okay, so we will start by defining dissolution. Well, simply, dissolution is the process by which the solute goes into solution. Remember the seawater example from our last video? We used the term dissolved when we were referring to the salt after it got inside the solution state. The solid solute, which was the salt, dissolved in the liquid solvent, the water, to make the salt water solution. What happened in the molecular level? Salt, or NaCl, is composed of the positively charged sodium ions and the negatively charged chloride ions, which are packed together in a cubic lattice via ionic interaction. Water molecule, on the other hand, has 2 hydrogens and 1 oxygen, bonded by covalent bonds, and a special type of dipole-dipole interaction, that is the hydrogen bond, is the one responsible for tying all water molecules together. When salt is placed in water, water molecules start colliding the salt crystals until an ion comes out. That ion would interact with the water via ion-dipole interaction. In simpler words, the chloride ion would be attracted to the partially positive hydrogens and the sodium ion towards the partially negative oxygens. Yet, this is not the only thing happening. Actually, while some molecules come out from the lattice and being stabilized by the water molecules, others, when coming close proximity to the crystal lattice, would return to it, separating out from the solvent and recrystallizing again. The two processes happening are the dissolution and the phase joining. We can call it crystallization or precipitation. At first, the rate of dissolution is higher than crystallization. Then it starts to decrease as we add more salt. And at a certain point, they become equal. And that is the point where solubility is determined, as we said in our previous video. Adding any more salt would be in favor of the crystallization rather than the dissolution process. Now, if we make any solution, we can imagine what can happen inside. But wait, is it like that for all solutions? Actually, solution formation depends fundamentally on the intermolecular interactions. What does that mean? It means that the solution will form if the solute-solvent interaction is of similar type and strength to the intermolecular forces of each component separately. Referring to the salt-water example again, the ion-ion interactions between the sodium chloride ions and the dipole-dipole interactions between the water molecules were replaced by ion-dipole interaction when the solution was formed. All 3 interactions are classified as strong polar interactions. A polar solute was dissolved in a polar solvent, and polar interactions formed the solution. If non-polar substance like oil is dissolved in water, it won't dissolve. Yet if an organic solvent was used to dissolve the oil, it will easily dissolve, as the two are non-polar. Probably you have that aha moment. And some of you already remembered the famous saying from science classes, likes dissolve likes. Okay, now what is the relation between solubility and dissolution? Well, generally, we can say that solubility is an inherent property of a substance, while dissolution is a process by which the substance goes into the solution state. Some refer to this solubility as an endpoint representing dissolution capacity. Dissolution is quite important in pharmaceutical development, and an essential test to pass for most dosage forms is the dissolution test. So, more in-depth videos will be uploaded discussing this important topic. For now, this video comes to an end here. Hope you enjoyed it. Here is a recap of what has been said. You can take a screenshot and look at it later. Don't forget to share your comments down below, and as always, stay fabulous wherever you are.